Hi, this is Dave. I'm a chemistry professor in a Western Pennsylvania university in the USA. I'm working with a rechargeable battery secondary cell, and what you're seeing there is a zinc anode and a stainless steel cathode, and I have it insulated. I'll show you how I'm rigging this up. I just charged this up, and in about 15 minutes you'll go over 2 volts. Now don't get excited, it's not going to stay there, it's going to drop down. It's not at equilibrium. What I use is a AC/DC charger, and that'll take you down to 5 volts, 500 milliamps. I give it about 10 or 15 minutes. It's dropping there. It's going to drop down to 1.4, 1.5 volts, and it doesn't self-discharge much after a few hours. It's holding a charge pretty well, so it's not a glorified capacitor. Now, what I'm experimenting with is various electrolytes, and I work with deep eutectic ionic liquids, gels, and what I have here is a boric acid sodium hydroxide buffered solution, and we'll show you how we actually prepare the stainless steel. I'll show you this. I'll pull it out of solution here. So I've got this, I guess it's a polyurethane matting you get at the dollar store. So let's show you how I rig this up. Prototypes very frequently are not very exciting looking. We're interested in exploring the chemistry and the energy storage utility. Before I take you to the next room here, see, we're down to 1.64. Let's do a quick short circuit. That's open voltage. What are we getting here? You're getting about 8 milliamps with these conditions. Yeah, that's a short circuit. Of course, you got to work with your electrolyte. I can increase the concentration. There goes the voltage. See, it's going right back up. Okay, let's take you to the next room. And we're in the lab. Now, this is how I do this. On eBay, you can get them anywhere, of course, but stainless steel socket head screw caps on eBay. I get them from, if you want to reproduce this carefully, Albany County Fasteners. It's on eBay. And these are the stainless steel. Now, it's not galvanized, it's stainless steel. And down at the dollar store, you get some stainless steel scrubbers. And I get these for $1.30 locally. I like the stainless steel. It's magnetic, so there's no nickel or very low nickel. So you got chromium in there. I'm on the alkaline side, of course, with the borate. Boric acid, when you dissolve it in water, is actually acts as a Lewis acid. It's it loses a proton, boric acid. But I have a sodium hydroxide boric acid buffer there I'm using as electrolyte. And what I do is I cut some of this stainless steel. It's very easy to cut with scissors. I wrap it around the screw so to increase the surface area. I wrap that around real tight, and then I put this rubber matting. This is what I'm using. It's not rubber, it's probably polyurethane. I cut some of that as insulator and wrap it around real tight, and then with a hot glue gun, I'll seal it together. So here's what it looks like. And I've got some of that stainless steel scrubber wrapped real good around the electrode, and then a little bit of glue, and I even put some on the bottom to prevent a short circuit, but I don't let it get anywhere near the zinc electrode. You can get your zinc, of course, from the lantern batteries, the 6-volt Everetys, and you can grab that, take your battery apart, and get a supply of zinc. You can grab those 1.5-volt alkaline batteries, and the zinc casing, you can obtain it that way very readily. And so this is where I'm working now, and the electrode is holding up pretty good this way. So wrap plenty of that stainless steel around the stainless steel screw, and that's where we're at. I'll keep you posted on the developments. I'm interested in self-discharge of this cell with repeated cycles, some other things. Thanks for watching. Bye for now.